Our next question deals with quadratic sequences and series. Now, folks, I love this. I love this question. And who sent us this question? Let me just see. It was Elaine Mampuru. Elaine, I've got a friend with a surname Mampuru. I hope you are his daughter, Eloasi Mampuru. Okay, Elaine, let's talk about your question. Your question says the following. It says you've got a quadratic equation there. So we know that that means there's the second difference is constant. The first difference isn't constant. Then they say something strange. They give us term 11. Term 11 is 125. And then they tell us that Tn is the general term. But look at what they say about Tn. They say that Tn minus Tn minus 1. Now, what does that mean? It means if this is term 15, this will be term 14. So it's the difference between two consecutive terms is given by this expression. Okay, so if we work out, let's just for argument's sake say T5 minus T4. So n is 5, n minus 1 is 4. So it means this n must be 5. Gives us 15 minus 4, which is 11. Okay, so remember n was 5 here. If we go for another one, let's go for T4 minus T3 and see what we get. Now n is 4. Okay, so if n is 4, we get 12 minus 4, and that gives us 8. And let's work out one more. Let's make n 3. Term 3 minus term 2 will be, this n is now 3, so 9 minus 4 is indeed 5. So what did we learn from this little exercise here? And this is, Elaine, where the trick lies. You've got to find out what the difference is. And is that difference constant? Now let's have a look. We have the terms 11, 8, and 5. So we can see that this difference here is a constant of 3 for that particular distance. So all we need to do now is we need to work backwards from term 11 to get to term 1. Okay, we have term 11 as 125. Now I can hear you asking, but why don't you just go down and find T1? You can't find T1 this way. You've got to work backwards. Okay, so let's see. From term 1 to term 11, there's 1, 2, 3, 4, there's up to term 11, which is 125. To get to term 1, we've got to take this 125 into consideration and the number of terms that are between 1 and 11. There's 10 terms there, and each term differed by 3. Okay, so to get from 125, I've got to work backwards. Let's see what it is. I've got to work with the 30. Now the question is, do I add or do I subtract that 30? Well, I'm moving backwards. Okay, so what will term 1 be? Term 1 will be the 125 that I have working backwards 10 threes. Okay, so that will give us a term 1 of, I think it's 95. Yeah. Okay, so usually we call this here a recursive relationship. It means you know how to get from one term to the next. They tell you how to get from one term to the next. Beautiful question. Matrix, take note of this question. I haven't seen one like this for quite some time. Beautiful. Make sure you know what to do. Let's go to our next sequence question, which is also from Elaine. It says the following. The first 24 terms are given. We've got 24 terms in this arithmetic series. So they tell us it's arithmetic, so we know there's a constant difference between the terms in the sequence. Now they say, find the sum of all the natural numbers from here to there. So in other words, from the first term to the last term, which is not divisible by 7. Another tricky question. They've given you terms that start at 35, ends at 196, and then they say, now we can see that the constant difference between those terms is indeed 7. Okay? Now they ask us, find the sum of all the natural numbers now between those two endpoints that are not divisible by 7. Let's see what we can do. This sequence here, the 35 plus 42 plus 49 plus ... plus 196, this is the sum of 24 terms. That's what they tell us. That's 24 terms added together. Now, if we look at this a little bit closer, we can see that from one term to the next, you've got to add 7. And as it is, these are all divisible by 7. That's 7 times 5, 7 times 6, 7 times 7. Okay, so what does this give us then? This sequence here is the sum of all the natural numbers between, what is it, 35 and 196 that are divisible by 7. Okay, so if we've got all of those that are divisible, remember we're looking for those that are not. So if we remove the ones that are divisible from another sequence, then it leaves the numbers that are not divisible. So the second sequence we've got to look at is the sequence that says 35 plus 36 plus 37, and that will continue up to 196. And if I've got that sum, this is the sum of all the natural numbers. I'm going to try and write it in here, between 35 and 196. So this will be the second sum that we are going to calculate. This here is the first sum we're going to calculate. And then those that are not divisible by 7 will be sum 2 minus sum 1. So the answer to this sum minus the answer, or the answer to all the natural numbers between, minus those that are divisible by 7. You've got to interpret it like that to be able to answer the question. So let's not waste time. Let's find the sum of all the natural numbers between here and the 196. Okay, so what do we know? We know for sequence number 2, or for sum number 2, we know the first term is 35. We also know the difference here is 1, and we want to know how many terms are there in the sequence. Okay, so these are natural numbers, folks. So the number of terms in the sequence is 196, the top minus the bottom, plus 1, gives you the number of terms in your sequence, and that gives us 162 numbers in that sequence. So the sum of 162 terms in the second sequence is n over 2, and n over 2 is 81, folks. So we're going to use the formula n over 2, a plus tn, the last term, because we have the first and the last term. So this becomes the natural number here, 81 162 divided by 2 gives us 81, the number of terms I meant. The first term is 35, the last term is 196, and if you find that sum gives you 18,711 is the sum 2. Okay, so this is our, let me write it in another color, our S2 that we wanted to calculate. Now we need to find the sum of that top lot. Now remember there's 24 of those. So the sum of the 24 terms that we need here is 12 times the first term plus the last term. So it's 35 plus 196. Now folks, a little bit of calculator work, accurate calculator work, will bring you to 2772, and that is the sum of the terms in S1. Okay, so therefore, the sum of the terms not divisible by 7 will be S2 minus S1, which is 18,711 minus 2772, and that gives us 15939 as an answer. And that was asked for, let's see, for 5 marks.